I mean, would it be better just to make it break, like we add the class and don't define any members on it, and now
That's the proposal.
well, but you're adding the proposed API says to add the is supported. I guess the problem is if we extend it, it'll still inherit the thing. So we need to. All right, so we need to do it because we need to mask out the inherited member even on the
right
type specific subclass. Sad. I really wish C# did not allow base class invocation of static members. Sorry, derived type invocation of static members.
Well, it's kind of good and bad because that's also the thing that enables us to say that SHA-3 basically has all the static members from SHA-2 and SHA-2, from SHA-3 and SHA-2 and SHA-1. Right, so that's the, okay, SHA-1 is a bad example, but SSE we have done that, right? So that you can have, that you don't have to reason about, or was this method introduced in SSE2 or SSE3, right? If you require SSE3, you don't have to worry about that. But I guess that's unfortunate. Yeah, are there any concerns with that API? Otherwise, it seems very reasonable to me. Is this the only one we're adding? Because it says something like...
No, it would be for all classes. So all classes under system runtime intrinsics ARM and all classes under system runtime intrinsics x86 would have respective ARM64 and x64 subclasses where they don't exist today.
Gotcha.
Yeah, how often does x86 versus x64 make that distinction?
Very few places. There's only a couple intrinsics around dealing with long, namely dealing with long as a as an actual value rather than a reference. In which case it has to be in the register. But the few places where it does exist, we have exposed the x64 class, and so there are cases like there's one for SSE41.x64, but AVX2 doesn't have one today.
And so when I'm running something, I know that I'm on a specific platform. What benefit do I get from being explicit about checking for ARM64 that is supported?
It tells you that you're running on ARM versus running on x86. So the JIT, so you can use ARM intrinsic safely under there, and then the JIT will elide the dead code paths. So you're expected to check for, is this particular instruction set supported, which includes checking for baseline instruction sets, because you could be running on ARM, for example, in which case the x86 baselines won't be supported.
Okay, I think it makes sense to me.
Yeah, I guess the question is, should we add the second half of the check or not? So if you said arm.sha1.arm64 is supported, but you're on ARM32, should that return false? Because why are you asking an ARM64 question? And given that no one should really be hitting these sub ones because we haven't defined any instructions uniquely under them, I would be fine with saying let's just add the redundant check for the int pointer size.
Well, the way it'd probably be implemented is the same way these supported are today, which is we actually have two copies of of the class. One is used for the ARM compilation, and it always returns false for the x86. And then and then there's a separate implementation for x86, which is recursive, and the JIT handles. And there's already all the hookups for the JIT to handle that today.
Okay, but so it's going to be the same. The JIT fills this in?
On the platform where it can return true, the JIT will fill it in. And on platforms where it can't return true, it will always be false.
Okay. Then, yeah. I would recommend that we make it have the behavior of the commented out sub-expression, which is because it says ARM64, even though it's not actually, the instructions that are talking about aren't actually relevant to ARM64, that it should return false, because don't let things get muddled.
Right, that's the way they all work today.
Okay.
I mean, what's a bit odd with that pattern, though, is I thought is supported is effectively guarding the members on that type, but in this case, it wouldn't guard the members on the ARM64 type, it would guard the members on the containing type, right?
It's guarding the members. So in this case, SHA-1.ARM64 will also expose the members from ARMBase.ARM64 because that's the way the C# compiler exposes them. And so the is supported is basically saying I'm 64-bit and I support SHA-1. And it avoids the weird scenario where you would dot off of it and it would return true even though SHA-1 returns false. So there's still members that you can access on it.
So basically what that means is if I'm doing SHA-1 dot blah blah blah, in order to know whether blah 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 is valid, I still have to only ask SHA-1 dot is supported. But if I want to access other members on SHA-1 dot ARM64 dot blah blah blah, then today the problem is because the is supported is defined on the base type, it would lead to misleading results.
Right.
I believe there are no unique methods exposed via SHA-1.ARM64, which is why we're in this state. We didn't define that class, so it inherited it from the base class.
Correct.
Yeah, so I guess what I'm unclear is like what calls are actually guarded by this new is supported thing? Like what can I call?
Nothing.
Is it literally just for then
if you did the check, then it would tell you that and it was supported, then you'd be able to call any of the ARMBase.ARM64 methods and they'd just work. If you call the check and it's not supported, then the code path will never be hit and you don't have to worry about it. Now there could be a scenario where a user does SHA-1.ARM64.is supported and they call an ARMBase.ARM64 method and they're not realizing they're doing that. But that might be something that we should handle by an analyzer.
I guess I'm confused now because if it guards nothing, why is that important to have these things then? Like what mistake will people make?
The issue is that SHA-2, the way it works when you have an actual x64 class is the x64 class is a combination of the containing classes is supported and int pointer size equals 8 effectively. So SSE2.x64 is both SSE2 is supported and int pointer size is 8. However, if you move to AVX2, for example, which doesn't have an x64 class, then when the user types avx2.x64, the compiler allows it. But that .x64 is actually SSE41.x64. And so you think you're checking against AVX2 x64 is supported, and you might assume that you can then call AVX to methods. But in actuality, you're calling SSE41 is supported.
Yeah. So Tanner, is there right now any reason that we would want someone to ever say SHA-256.ARM64 is supported?
Not today.
So what if instead of doing what you have proposed here, we do editor browsable never, public sealed class ARM64 curly curly. So we define it, and you will now fail to compile if you said SHA-256.ARM64 is supported, because now we've masked out the base class, or we've masked out the nested type from the base class.
I think that would be fine.
Okay, that would make more sense to me, because otherwise it's a bit weird to have. I mean, it seems like you're asking the wrong question anyway here, so.
Yeah, and that's the point, is the derived type floated up from the base class.
Right.
And you're not actually walking through a thing that makes sense to walk through. So I think what we want to do is mask out the class. So define it, give it no members, don't inherit the base ARM64, and then just put editor browsable never on it.
That would make sense.
So
to me. We should validate
that will be a recompile breaking change, like if someone was doing this already, but it turns out what we're telling them is the question you asked made no sense.
And that's probably better than a potentially silent breaking change.
Yeah. And if there is a later ARM64 extension to the SHA-1 things, then we can remove the EB never and add the base extension if that's what we've done in the other types.
And remind me, why did we make the SHA-1 extend ARM base, for example? Because it's basically just modeling the instruction sets, right? It doesn't, like, people don't usually call ARM base members through SHA-1 either, right?
Right. It's not normally the case, but because the checks are hierarchical in nature, SHA-1 support implies ARM-based support.
Yeah, then I think what Jeremy said makes a lot more sense to me, because basically you're selectively hiding branches that don't make sense. Yeah, I think that makes sense. All right, then let me try to write this up in a meaningful fashion. Is it just for ARM64, or is this for all the nested classes?
It's for all of them.
So this would mean you would say this would be editor browsable never. Editor browsable, whatever the freaking enum is called. All right, so I think that makes sense to me now. Let me go here and paste it in here so we can all agree on what our vote makes sense.
Looks good to me.
Yep.
All right, then let's approve that one. It would be this one will be gone. This one will be added. Somebody apply breaking change already. That's good. All right, sweet. So then next one is that
34929. That one. So we exposed vector64 create methods. We didn't expose vector64 create scalar for double long or ulong. They currently can be done via the create methods because they just take one argument. But it can be difficult for some users to resolve or find them. So the proposal is just we also expose create scalar methods for parity. We're already exposing create scalar for the other 7 types. It's just these ones were peculiar because they are the same size as vector64.
And we probably also can remove create for these types.
That's a breaking change, so we wouldn't be able to.
Okay.
I understand. So basically you said that's why it's hard to discover, because we don't have overloads that basically they would look for a create scalar, but they wouldn't be able to find it because it doesn't exist. And the create one has an overload that basically does the same, but it doesn't follow our naming conventions. Is that fair?
Right.
Should we at least hide them then?
I don't think there's any harm. They functionally do the same thing. The difference between scalar and the non-scalar for every other type is whether it's a broadcast or fill in the first element. In this case, that means the same thing. So I don't think there's any particular harm in having both.
And is it only for vector64 or is it for all vectors?
It's only for vector64. In every other case, the underlying t is not the same size as the containing vector.
Gotcha. And so the only overloads you would literally add are these 3?
Yes.
I'm just looking at the existing definition of vector64, and like we have both create, we have create scalar, and we have create scalar unsafe. And so which ones are they equivalent to?
These are equivalent to create scalar. It's so create scalar means create a vector where only the first element is set. In this case, the first element is also the only element.
I guess what I'm asking is like, so basically you just said there's an existing overload that already is there, but you just it's equivalent to the existing create scalar. But like we are creating the create scalar overloads for double, ulong, and long.
Sorry, I'm not sure what you're saying.
I believe it's create scalar for these 3 types will be an alias for create for these 3 types.
Yes.
Okay, that makes more sense now. I guess why I'm confused is because you already have create scalar ones, so this wasn't a complete oversight, right? We basically, when we added the create scalar ones, we only added them for some types, but not for all of them.
Right.
And that was deliberate unintentional?
We didn't add them. We didn't add them for the 3 types where the t and the vector were the same size, where they're both 64 bits. And I believe that was just an oversight.
Makes sense. Yeah, don't try to be nitpicky. I just try to understand the decisions that we made before and making sure that we are not flip-flopping with decisions.
Right.
Is this something we only need for ARM64, Tanner, or do we also need it for AMD 64?
This type exists for, it's a shared type, but it doesn't have any actual use on x64.
Okay. Because there's no namespace here, so I don't know.
Oh, it's system runtime intrinsics.
That's why I added it here, because you have the same problem.
Okay. I just saw the ARM64 label and thought we were in a architecture scope, but never mind.
Yeah, Tanner is sneaky. He's sneaking an additional feature work that has nothing to do with ARM. All right, so then this one good or something else?
35037, and then we can just go in order after that one.
037, this one, right?
Yes. So this one covers various move intrinsics, is what they're referred to in the ARM architecture manual. They're largely just intrinsics that take a scalar value and move them somewhere into a vector. In the case of the first ones, they take the scalar value and splat it into every element. So this is what vector64.create would use under the covers, for example. It's equivalent to the broadcast instructions on x86.
So the type doesn't exist yet, so we would define the type as well, right? So
which type doesn't exist?
ADV SIMD?
No, that type exists already.
I don't see it. Maybe we have this problem again that I'm indexing something that is like old. Did we add this in 5.0 maybe?
Yeah, it's 5.0.
I see.
All of ARM is new for 5.0.
No, I mean the advanced SIMD type. Then I guess is that
right? It's under the ARM namespace.
Oh, gotcha. So then okay, so this is a brand new API. Then probably also doesn't matter what's on the type. Usually, what I like to do is look at the type to make sure that the new things we're adding kind of make sense with the existing thing we already have. But
well, you could look, but it's about 1,000 intrinsics that we've already reviewed.
Yeah, it's mostly for naming conventions. So these ones don't have floats and doubles. Is that intentional?
Yes, I believe so.
Also no long or long. What that matter?
The long and ulong are 64-bit specific, and so they're a little bit lower.
I see. Makes sense.
I still think can implement floating point versions because it's going to be equivalent to duplicate selected scalar with index equals 0.
Yeah, that might be the case.
What does duplicate here mean? It just means you take this one value and you basically blast it into all the other elements?
Yes, broadcast the value.
Is that the term you're using elsewhere? Or is that something... I guess
we use broadcast for x86 because that's the name of the x86 instruction. I chose duplicate here because that's the name of the ARM instruction, which is what we've done elsewhere.
Yeah, that makes sense then.
Could these ones be accomplished by an optimizer? Just seeing you access a specific index and call duplicate to vector?
Not trivially. In this case, these are the base instructions that we would generally use to optimize other algorithms like vector 128 create.
Okay, so each one of these maps to an explicit instruction.
Yes.
Okay.
So the general helper that people would normally use is vector 128 create, for example, and then we would implement vector 128 create using duplicate to vector 128 or a sequence of inserts or other optimizations in the JIT.
Yeah, to a certain extent, I mean, like that's the point of Intrinsics, right? That we try to give developer expressiveness rather than relying on magic optimizations, right? So what does vdupe mean in this context?
Vdupe is, so dupe is the ARM64 instruction, vdupe is the ARM32 instruction. We're not implementing ARM32 for .NET 5, but we've still been documenting which ARM32 instruction it corresponds to.
But it would have the same behavior, just different size. So you would just also call it duplicate to vector 32 probably then, or...
No, they're also vector 64 and vector 128 on ARM32. Unlike x86 and x64, which basically use the same instructions and same instruction names, just with different register support, ARM32 and ARM64 use different instruction names.
I see. So basically we would have the exact same methods.
They're largely functionally equivalent.
Yeah, there would be the same methods, except that we just implement them by emitting a different opcode.
Yes.
Yeah, okay, that makes sense. Okay, then... Duplicate selected scalar to vector 64.
So in this case, it's similar to the previous, but rather than taking a raw scalar value that might exist in, say, a general purpose register, this picks the scalar from an existing vector. So you could say broadcast the first element from a vector to every element of this new vector you're creating. Selected scalar is the naming that we've used for some of the other intrinsics we've already approved.
Makes sense to me. We usually use bytes for indices too.
In the case of the intrinsics, we have been, because you're only allowed to encode a limited number of bits.
And what if we? I guess all these bytes here would also be whatever our attribute is to say this should be a literal, right?
If and when we add it, yes. The JIT is not limited to them being literals. It will just generate very, very inefficient code if it's not.
Right. But like fundamentally, the opcode encodes the index, correct? Like it's not part of it. It's not an intermediate, right? Yeah, that's what I thought. Okay.
Yeah.
All right, I guess this is now the same thing except for different data types.
Yep. Just extending duplicate to vector to support long and ulong. And then in the latter case for insert selected scalar, it is picking a scalar value from a vector and inserting it into the specified index of a target vector. So in this case, if you scroll right a little bit, it's
you say that it's not that easy. Okay.
It's taking value index and inserting it into result index, and all other elements are taken from result.
I'm slightly confused. So the comment says it's effectively an assignment result. Result index is assigned to, I guess, value index or something.
Right. So you have an existing vector that say has values 1, 2, 3, and 4.
Right.
And you have another vector that has values, say, 5, 6, 7, 8. And so you're going to say insert into the first vector at element 1 the value from the second vector at element 3, in which case it would return 1, 2, 3, 8.
I guess what confuses me is that you have an argument called result and you still return a value.
It's the value that all other elements are taken from. I don't think we have a good name for that. We've used upper in the past, but that's generally when it's impacting the lowest element. And then we can't use value because value is the name for the thing that we're inserting.
So when you say insert, like, what does that mean? You shift all the other ones down? Is that logically what happens?
No, like it's like taking, it's like an array assignment. So if you imagine a vector as an array, then you're taking the element from value. You're basically doing value or result index equals value index. So the rest of result stays the same, and you're only modifying the value at a given index.
The C++ intrinsics for like insert PS use destination and source for this. Could that make sense here?
What I don't understand is why do you have to pass in result at all? I understand why you would have to pass in result index, but
because you need to know what the remaining values are going to be. You're only modifying one index. So if you've got a vector that contains 8 elements, you're only modifying one of those 8, and you need to know what the other 7 values are.
Yeah, of course. Sorry, my brain has not seen enough coffee, apparently. Okay, now it makes more sense. Yeah, erase the reference types, that's what fucks me up. Yeah.
Why insert selected scalar defined only under ARM64?
I didn't see an equivalent for ARM32 for selected scalar in particular.
I think you still can implement it for vector 128 float, vector 64 float, and doubles, because it's effectively going to be just move. If you have result index and value index is constant, you can figure out the appropriate registers.
Is it still going to be a single instruction though?
Yeah, it's going to be we move between C or D registers, I guess. But I guess Tamar can here. Probably knows better.
So I have to say,
yeah, I don't see like equivalent that looks like the like ins instruction in ARM32 spec. But I guess I can dig it when I start implementing this and see if we can extend this to ARM32 and ARM64.
Yeah. Kind of the order of these instructions is kind of weird. It's very hard to see whether you missed any types. Still trying.
They're in order by the namespace names, which is the same way they're ordered in metadata and enumeration. So it's byte, int 16, int 32.
I guess, yeah.
Single S byte.
Oh, that's why, yeah. Because I'm looking at this, I'm like, Jesus. I just try to find the difference between the top and the bottom, and I was like, that requires more mental gymnastics than I'm willing to. I guess double is missing, long, U-long, right?
Yeah, max. there's no overload that deals with long, U-long, and double for the one that takes a vector 64 value, because there's only one element, right, and there's no corresponding overload of the instruction.
Yeah, I guess it's literally just a normal scalar assignment to a particular thing, which we already have probably, right? Yeah. All right, then unless somebody else has concerns, this looks good. After I convinced my brain that it does.
So the vector 128 value overload for first group of insert selected scalar. Basically, can you insert from vector 128 into vector 128?
That's what the second group is.
Okay. So like another question. So can you do this for vector 64 result?
I don't think this is one of the ones where you could, but let me double check.
Because it looks like the instruction itself accepts immediate up to the maximum number of elements in vector 128, but it means it's still possible to use it for smaller types, such as vector 64.
I didn't expose the other ones because the index one is always for 128 bits. The result is also always 128 bits. So it's not a safe operation because unlike the ones that normally operate on 64, it would not zero out the upper 64 bits.
Which is fine because vector 64 and vector 128 are being in the same register. It's just only the lower part is going to be used for vector 64.
Right, but we don't have anything that returns a 64-bit result and doesn't also zero the upper 64-bit bits today.
I guess my question is confusing. So basically, what I'm asking, can we have insert selected scalar that returns vector 64 of t and accept vector 64 of t as a result, and say accept value or where we're inserting from also is vector 64 or vector 128?
I don't think we can because the actual instruction returns 128 bits. And if users really care about it, then they can explicitly do the operation so that they're accounting for the fact that the upper 64 bits are being modified, and then they can call get lower to get the 64-bit result.
So what do you mean instruction returns vector 128 result? Instruction only modifies a register, which we can look at as a vector 128 or vector 64, and if it doesn't modify the upper part.
No, the result, if you look at the operation under the instruction, the result is always 128 bits. So if we took 64-bit as a result here, and we returned 64, then behind the scenes, the processor would still be reading a 128-bit result and preserving the upper bits, whatever they were,
Okay.
in the returned value.
Why is it unsafe?
Yeah, it's unsafe because every other place the hardware zeros the upper bits. We don't have anything that lies about the size that it's taking today when it involves a result.
Well, I don't think I agree, but let's move on here. So they probably need to dig more specs.
Yeah, the nice thing is for the API review, you don't have to agree. We can still approve that. But you should probably take this offline. All right, so one more down. So which one is next? No, this one in order.
We can just go in order unless Igor has something in particular he wants to push up.
No, actually, I would favor to review this one because it's larger work item, and I need larger work item to keep up working with Intrinsic.
So this first set is just called shift logical because it doesn't strictly perform either a left shift or a right shift. Which direction the shift is selected on a per element basis based on whether the shift, the corresponding element in the shift operand is positive or negative. If it's positive, it's a left shift. If it's negative, it's a right shift. And it's always logical, which means if it's a right shift, it will insert zeros rather than carrying the sign bit. Igor, at the very bottom of the issue here, suggested that we only expose the versions that take a unsigned operand for shift logical. I don't necessarily have a preference.
What's the rationale for that?
It reduces the number of overloads, and if you're in C#, then shifting for a signed integral value is always arithmetic, not logical. And likewise for unsigned, it's always logical rather than arithmetic. So you could still get the total sum of desired operations. You might just have to insert a cast if you wanted to do logical shift on a signed input. But that's the same as you'd have to do in C#.
I mean, I would agree if it was just named shift, but since the name logical is in the name, I don't, or the word logical is in the name, I don't see why we would make people have to write the cast operators manually.
Yeah, I mean, to me, reduce the number of overloads, I generally agree with that, but this domain, it seems kind of a lost war anyway, because there's like so many of them. And yeah, given that there's already quite a ceremony involved in calling any of these methods because they all tend to have very long names and non-trivial type names, it seems a bit backwards to make people also write the cast.
I guess it's worth adding that the instruction itself called shift left in ARM64 spec, even though it can shift right.
Right.
Maybe confusion comes from logical here. Maybe it could be something else, not shift logical. Maybe just simple shift.
It's still doing a logical shift. So the alternative would be just name it shift and then have the signed versions do the arithmetic shift. But I don't think that's strictly clearer in the code. like when you're actually reading the code, if you just see shift and you've got a vector and a vector where you might not have the type immediately obvious, having it explicitly called logical helps disambiguate. And there's other cases below where we do need to call it logical, and we did the same on x86, for example.
Okay.
So what does this?
Yep.
Sorry, go ahead.
I think having logical in the name is good, and I think that there's no reason to trim the signed types.
Which means they just stay as proposed here, right? Because they're already listed.
Yeah.
Yeah, the only reason I suggested to trim up the size because we have not just one version of shifts. Like there's a logical saturate, logical rounding saturate, and logical mirroring saturate. And,
Oh, I see. So it's not like 4 overloads you're saving like 40 or something like that.
yeah, it will save like 30% because now we're doubling the size. And also it looks like on C++, well, they're not using logical, they just use instruction name for naming the intrinsic. But if they operate on signed type, they always do arithmetic, and if they're operating on unsigned, it's only logical.
Which is a bit different how x86 works, which supports it for either.
Right. Yeah, I mean, even though there's a lot of methods, again, like this whole domain has so many methods that it seems, I mean, we generally don't make people jump through hoops like that for these, so I think I'm okay with them as they're listed here.
Okay. I guess we should keep the name of second parameters count because this is what's been used for x86.
You mean instead of shift count?
Yeah, that's what we named it on x86, it looks like.
Yeah, I think that makes sense. And then shift logical scalar, how's that different?
It's a different so for all of the intrinsics that operate on a scalar element, which includes vector 64 of long, ulong, and double so far, we've named them scalar because they only operate on a single element.
But which element are they operating on? The first or?
Well, the first is the only element. There's only one. Because the vector is the same size as the underlying type.
Oh, I see. Fair enough. Yeah, I guess that makes sense. Okay. What does rounding mean in this context? It's not what I think of rounding, probably, right?
Did you scroll down on the screen?
Oh, sorry, I scrolled down on my screen. Here we go.
So it's similar to rounding with normal. So shifting is similar to division by 2 or a power of 2. And so this basically just accounts for rounding error there. So if you did 5 right shift 1, it would return 3 rather than 2. Or
okay.
something like that.
Yeah, my bit fitting days are a little bit far away, so I'm not following entirely, but
it basically does that operation described.
Yeah, that's what I'm looking at, and I'm like, I'm trying to like do this in my head, and it's not happening. I'm sure Carol and Bruce can do this in their sleeps, but like I have to stare at this for a while to see what's happening. All right, so
it basically adds one and then does the shift.
Yeah, I think that's how I read it, but all right, so let me just copy and paste the thing over.
So the reason the math is slightly complex is because for a left shift, it's going to add nothing, but for a right shift, it's going to adjust since you have to account for rounding when right shifting.
Right. Oh yeah, my machine is not happy. Alright, let's try this one more time. This time hopefully I can copy and paste the APIs. Yes, now I can. Makes sense. And then same thing there, rounded scalar.
And then shift arithmetic. These only support sign types, and just which also matches what we do for x86, since arithmetic shift only applies to right shift or to sign types, unlike logical, which can apply to either.
Right. Makes sense. Shift arithmetic rounded. I guess that's the same thing combined.
Yes.
Then unsigned saturating shift left.
Yes. Which left shifts, and rather than dropping bits that shift out, it saturates the value. So it will overflow to unsigned.max value.
Is that what we called it before? I mean, like, didn't we call it like saturated or something like that?
We just used the word saturate on x86. So add saturate, subtract saturate, etc.
Interesting. I guess in that case that is consistent with what we have done before, so.
And then same thing, but rounded saturation.
Yep, and then the arithmetic version of that.
And all these shifts, are they supposed to be all renamed count?
Yes, I already did that.
Yeah.
That's what my screen reads already. Shift arithmetic round set right. Okay, that one we have.
And then we're off the ones that can do either left or right shift on a per element basis and onto essentially all the same methods, but only left shifts and by a constant amount for all elements.
I see. So now we have basically overloads for shift left, shift right for all the ones we had before. And instead of taking a vector as the second argument, we just take a constant that is a byte.
Yeah. Yes.
Yep. I think in that case, unless somebody has a desire to walk them all, I think we can say that's it, because that it seems like rinse and repeat of the pattern. Any objections to that? Otherwise, I'll just go all the way to the bottom.
There's some more after we scroll down a little bit.
I was afraid you would say that.
Do we know what the processor is going to do if you ask it to shift 100? Does it just give you 0? Does it error? Does it?
Will format your hard drive.
But for immediate version, you probably can, because it's going to be encoded as immediate operand and only has limited resolution. But for register version, I don't know.
And what's the JIT going to do if it gets an immediate that it can't encode? Throw a JIT exception?
So if we get a non-immediate, if we get something that isn't a constant, we emit a fallback that will throw platform, or that will throw argument out of range exception, and we'll do the same if we get a constant input that's too big.
Okay. So if somebody says shift right logical rounded, comma 100, they'll get an argument exception because that doesn't make any sense.
Yeah.
Okay.
Which seems reasonable.
Yep. Just understanding our failure paths.
For a register version, it looks like, at least what described in spec, that it ignores bits higher than 7. Meaning, if you pass some value that is invalid, it will just do some masking and uses only lowest 8 bits.
Right, but I think that the question is, what happens if you shift a byte by 9? And that I do not know.
And probably will shift by 1, because it will ignore the 4th bit, which is 8.
But for if the value for shift, which will soon be count, is a variable expression, then you're running it through a validator that checks against the size of the t in the vector.
No, we would just pass the vector as given to the instruction. The hardware doesn't throw on that, but I don't know what it will return.
Oh, but I thought you said if it was a variable expression, then you're running it through a thing that checks the bounds.
For the one, so for the ones that take a byte shift, we make sure that it fits into the number of encodable bits.
Mm-hmm.
For the one that takes a vector, we will do no modification to it and no checking.
Yeah, we just emit an instruction, and what looks like they describe in the operation for this instruction, that it does masking and only take into account the lowest 8 bits. Meaning, if you pass 9 in one of the register lanes and trying to shift byte, it will effectively shift it by 1 instead of 9.
Well, so 9's less than 8 bits.
Well, not 9. I mean,
a shift count of 9.
Right, but I think the question is if you shift so normally if you shift an int by more than 31, for example, the result is undefined, which is why C# inserts an and 1f against any shift count that you provide.
Okay.
So I think the question is, what does ARM do in the case that you pass 32 to an integer, to a 32-bit int shift, which is encodable, and that I don't know.
Okay, so you throw if a const isn't encodable.
If it's not encodable.
But if it's a variable expression, so you're falling back to the indirect shift count version, then you just get whatever the platform does.
Right, which the hardware menu or the operation for the instruction doesn't clarify. It just says it left shifts by the shift amount. So we'd have to test it and find out exactly what the behavior is.
It looks like for this case it will return 0. Like if you shift integer to the left on 32-bit, when 32-bit shift will ignore the upper bits of the result. For saturating ones, it will return the maximum value, but for non-saturation version, it looks like it's just returns 0.
Okay. Yeah, I mean, ideally we'll have some tests for these things so that we understand the behavior before people complain about it.
We have lots of tests.
All right.
I don't think we cover such corner cases.
All right, so
because if what they're masking is everything down to anything that would fit, less than or equal to 64, if shift byte 9 is you get 0 because that fit in the encodable range, then that's very different and interesting than shift left 65, which now means 1. So being able to document what it does, have tests that prove what it does, are all goodness because this is public API. That is all.
Yeah, so I scrolled down to past the group, I think. Because that I think is the first one. Shift left logical saturated unsigned, where we have a new naming convention.
Yeah. So this does logical left shift, and I don't remember off the top of my head what the unsigned part means.
I guess it saturates up to maximum value of corresponding unsigned type.
Yes, that would be the case. So it would return sbyte.min value rather than sbyte.max value. Or sorry, it returns byte.max value because we return an unsigned result. That's why they're called unsigned. It takes a signed input and returns an unsigned output.
And it's bit blitting, so having just the high or doing shift to 0 of a negative number gives you back the unsigned cast interpretation of that number. Meaning the sign, you specified a signed type going in, but it just immediately casts it to unsigned before doing the operation.
I believe it casts it to unsigned after doing the operation.
So it would preserve the high bit and then cast? I'm just trying to understand what you give it, in the S byte, you give it 7F and shift it left 1. Are you getting back 7E or are you getting back FE? Yeah. Ooh, I know hex.
It looks like it's preserving the sign on the original input.
Okay. Which explains the need for the instruction. So
right, it treats it as a signed input and then returns an unsigned output.
Okay. Very complicated. I'm sure there's a formula that needs it.
Yes, for a RISC architecture, there are lots of complicated instructions.
Maybe they forget what the R stands for.
Well, I think reduced was the starting point, right? They walked their way up from there.
Yeah.
All right, so then I guess that makes sense.
I mean,
then?
the only question is do we have anywhere else that we've combined saturate or saturatedness and signedness, and are we being consistent in our adjective ordering?
Yeah, that's the same question I had originally.
I put the unsigned after because it's returning an it is effectively it's returning the unsigned saturation rather than doing a shift left logical, which is unsigned. So if we put the unsigned after left logical, I think that would imply that the input is bit cast and then done. It's reinterpreted and then done the shift versus saturate unsigned, which hopefully makes it clear that the left shift is signed and then the saturated is the unsigned thing.
Sure.
I mean, I don't know that it makes it clear because I had to ask the question, but I can buy the unsigned as last because it's the last operation done, even if that means that we're inconsistent with something else. So,
yeah.
All right.
I mean, consistency seems generally hard here because the instruction sets are not really consistent with how they do things either, right? So
this is if somewhere else we already had a thing that combined saturate and unsigned and was something other than shifting or whatever, like
right.
Like if it was, multiply scalar saturate unsigned. I don't know. I'm saying words. Then we're putting the adjectives in the right order.
Right.
Yeah, there is a sign saturating extract unsigned narrow.
Yeah, that comes further down though, right? Yeah.
I don't think we have it here, but I mean, if we're thinking about order where we should put unsigned,
right.
In the future we'll need to review instructions that will do unsigned and narrow.
Yeah, I think as a principle for constructing these names, I think putting them in the order in which they are logically occurring, I think makes probably the most sense.
Yeah, I can. So I guess the only question is, because we were talking about clarity, I'm aware the names are already long, but should it be, because we're putting signed after the shift, so the shifts grouped together, should it be shift left logical signed saturate, or does saturate imply signed?
Holy shit.
I don't know what saturate means.
I think saturate implies whichever signedness it was starting with. So if you're doing signed saturation, it will cap at s_byte.max value, whereas if you're doing unsigned, it will cap at byte.max value.
So if I'd known what saturate meant, then I would have known that meant that it was already a signed operation, and then unsigned comes later. So that is the order of operations. So
well, the saturate,
move on to the next thing.
The left shift is signed, whereas the saturation in this case is being done as unsigned.
Wait, what? I thought if I understood that you said saturate meant that it uses the bounds of the input type, then that would be the high bit is the high bit coming out of my example of left shift 7F by 1 would be 7E.
Well, yes, if the saturation was being done with a signed input. The way this works is it does a left shift, taking on a signed input. It converts that result into an unsigned result, saturates it, and then assigns the result back out.
Okay, and what does saturate mean?
Saturate means that if the infinitely precise value is over the max, then you cap it to max rather than truncating. So int.max value plus 1 is int.max value, not 0.
But if
Or
you are
negative
taking,
rather.
so if it's doing saturate based on the after the unsigned conversion, then that would mean all negative numbers turn into 0. But if it's doing saturate on the signed conversion, then it would mean they stay negative, and then they just turn into a unsigned representation of that negative number.
There's an intermediate here that is more precise than the total sum of bits you can represent.
Okay. But so I guess the question is the saturation done on the signed type or the unsigned type? Because if it's on the signed type, it should be left of the word unsigned, and if it's on the unsigned type, it should be on the right.
The shift is signed and the saturation is unsigned.
So should it be shift? No, because then it would sound like shift left logical unsigned. Okay, it's fine. No one will understand this. Move on to the next thing.
Computers are a mistake. I think that's the conclusion here.
To ask a silly question, Emo, is this what you feel like when I bring up crypto things?
Pretty much. I mean, most of the time it's just like, as you said, you just combine random words and then you're trying to ask questions.
Because before you've been like, this is crypto, no one will understand it, let's move on. And I feel like I got very close to something that you'd said previously with this one. So.
Yep, I mean, that's...
All right. Cool.
So this next one is shift right logical, and then it returns a result that is half the width of the input.
Is that how we called it before? I mean, I think I've seen lower before. Not sure about narrow.
Right. In this case, it's lower because it returns the lower half of the result.
I think I understand this one.
So what does narrowing in this context mean? Because you basically because you're cutting the tie basically, right?
Right. Rather than returning short, it returns S byte versus widening, which would take S byte and return short.
And all the vector 128s become vector 64, so they don't change their index counts in and out of the operation. 4 things went in, 4 things come out. They're just half the size when they come out. I get it.
Yeah, I think this one I can follow as well. Okay, now we have a rounded version of that.
And I assume we're saying lower here because there's somewhere that does narrow upper. Not necessarily on the shift, but just like in this universe.
Yes, there's a shift right logical and narrow upper.
Okay, so yeah, I think that name is very clear. And I don't mean that sarcastically.
No, not at all. I mean, most of what you work on has not names like that.
And then here's the shift left version, which widens.
Yep.
Taking vector 64 input, returning vector 128 output.
Why would widen need lower versus upper?
Because we're returning something that's twice the number of bits. So
you have to say where the bits go, right? Basically, where the
I guess for widen, upper version will operate on vector 128 as byte and will only read upper part of the corresponding register.
So if I understand the order of operations, it'll like this would do the shift left as vector 64 of S byte, and then after it's done with that, it will essentially just widen copy it to a vector 128 of short, which means there was never an upper to take into account unless this is on the weird infinitely precise version of things, in which case
they're all basically infinitely precise, but aside from that, the upper version takes a vector 128.
Okay, so we're naming the 64 lower so that it's an overload of the 128 lower, so it's different than the 128 upper.
Yes.
Okay. Cool.
Because we have to differentiate them.
And upper version also accept the lower part.
Yeah.
Okay. I was just this vector 64 going to the 128 with the widening. It's like I don't see where you need the lower versus upper because there are no upper bits. But if it comes from the vector 128, then I totally get it.
It's for consistency across the total group of methods for here.
Good with me.
Oh.
And then shift right logical and narrow saturate lower half and the
And that's quite a name. It's like a little.
Yeah. I think the shift and intrinsics have the most interesting name combinations, since they are various combinations of regular, rounding, and saturating. I think there's another term used in the manual in some places.
You should write a book, Tanner. Intrinsics, the annotated reference or something, where we have the full ref of all the APIs, and then you get to put random comments on APIs.
I thought that's what the recording and live streaming to YouTube was.
Yeah, but you don't get royalties from that.
We still have 21 viewers, to my shock and surprise. Shift right arithmetic and narrow saturate lower. And that makes sense too. And then shift right arithmetic and narrow rounded saturate lower. Sure.
For the parts where we're getting into ARM64, it was pointed out that due to the way that ARM32 encodes its registers, many of these, specifically the upper versions, should actually be on the base ARM class, rather than under ARM64 specifically. So that's just a number of these should be under ARM32 or under the general ARM rather than under ARM64. I don't think we have a complete list of them today, but I don't think API review largely cares as long as the names are correct. Is that right?
That is a very fair assessment, yes. I mean, the general gist is also that we care about, consistency, and that people can predict what it means when things under certain types, right? So long we are consistent in that regard, it's fine by me. I mean, not that we know any better where stuff ships and where they're actually available or not.
I feel like I've asked this before, but I forget the answer. If somebody regularly writes things with ARM assembly and they know that they're looking for squishhorn, do they have a good way of figuring out what we called squishhorn?
So today they can go to source.net, go type in advanced SIMD, and then type in squishhorn and they'll find it. Igor Bo wrote a tool for x64 that maps the names between the two of them. I'm likely going to ping him and see if he's willing to extend that to support ARM as well. I believe it's open source, so I could probably even submit a PR there, but that's what people are largely using today. There's been requests for a helper library that uses the C++ names, but I don't think that's something that belongs in .NET.
One thing we could be doing, that crazy idea, I would not actually do that, but you know that in Visual Studio, and I think VS Code is that too, there's snippets, which is, so for example, if you say for and then you tap, we generate a for loop for you. So you could imagine that we have snippets for all the instructions. So when you say squishhorn tab, we would actually extend this to shift right, arithmetic, and narrow rounded saturate lower, for example. That one would be very easy to do.
Has anyone tested VS with 4,000 snippets?
No, but like, I mean, there's always a first for something, right?
Yeah, and really you'd want it to be like arm.squishhorn and then it expands to the right static call on things.
Yep. Well, and then you'd have to have variants for the ARM intrinsic name, which may not be Squishhorn.
Right.
Anyway, just I know that that when we started doing the intrinsics, we said we wanted this, semantic names instead of just the assembly names. But as long as we've thought about the scenario where somebody's more familiar with the assembly name and we have a story, or we at least think that in the future we'll want a better story, then that I'm just making sure we've thought of it.
Honestly, I don't think snippets will be that bad, because even if you could say ARM64 dot, I mean, you can still do the same thing where maybe you don't get to say dot, but maybe you have to say ARM64 dash or something, right? We could come up with some convention where we could make the snippet sane, right? I just think it should be more of an editor thing. I think shipping a library might be a bit too heavyweight for that.
Yeah, that's fair.
Because it's mostly an editing experience. Because the other thing is also what's nice about it is that you teach people what the actual names are. I mean, not that it helps with these names probably, but I mean, presumably when you write code like this, you probably have like, I don't know, a certain set of instructions that you do a lot. And so probably as you're doing that, eventually you will, to just use the word again, you would saturate whatever knowledge you need to have to be successful.
You would narrow, saturate, lower the knowledge, yeah.
All right. ARM64. So that's I guess these are the same things as before, but with different data types again. Is that fair?
Yes, largely, except for the upper variants, which, like I mentioned, probably belong on the advanced SIMD class.
Yeah. Maybe I should write a note so we don't forget this. Can you? Okay, so basically, which one? The upper variants belong. Oh, freak me.
Yeah.
Hold on.
Most, but not necessarily all of the upper variants should be on the advanced SIMD class rather than ARM64.
Well, for shifting mask, I think all of the upper can be implemented on ARM32 as well.
Okay.
Oh boy. Here we go. ARM64. We are almost halfway through. It's not that bad. Only 600 APIs. Shift arithmetic rounded saturate scalar.
Yeah, so these ones are, I actually think a couple of these Igor called out aren't valid overloads. I misread the encoding, and it's actually only supported on long, in ulong.
Right. Yeah, that one I also care less about. Like, it's just,
Yeah,
just
so
remove the ones that you can't encode.
The first...
Yeah, first two are valid. Non-saturating versions are not valid.
Okay, so it's valid for saturate. It's not valid for the rounded ones.
And for shift arithmetic scalar as well.
Yeah, so the first two groups are fine, and the second two groups on the page there, we need to drop.
Igor, I admire your optimism. I just saw your message in the chat where you said after we have time, or like if we still have time. I'm not seeing.
Assume that at some point all of these, like, that there's going to be a JIT test or whatever that makes sure that all of these get encoded to the right thing, and at that point we'd notice this instruction doesn't exist, or this form doesn't exist, and we just remove them, which is fine.
We add emit tests that validate the encoding, and then we also add tests that call all of these methods from C# using various input types, including fields, locals, class variables, addresses, etc.
Okay.
We've got hundreds of thousands, maybe even close to 1 million lines of tests now covering all of x64 and ARM.
Cool. Just, yeah. So, I mean, at that point, I don't think any of us would have any, like, oh, but we approve this thing. It's like, whatever. It didn't exist. We don't care. We're not really, I mean, we're only looking at the shapes of things. So. Just saying, if you're removing these because they don't exist, then that's fine.
Right.
Yeah, so let me just aggressively keep scrolling down. Shift arithmetic saturate scalar looks familiar. Shift arithmetic rounded scalar seems also familiar. Shift arithmetic scalar. That doesn't sound familiar, but it probably should because it's a shorter version of it. Shift logical rounded saturated scalar. Did you actually write them or did you use a Markov chain? Like that seems like a generated names.
I spent many hours and lots of Mountain Dew reviewing these APIs and the manual and trying to get them right.
I believe that. Shift logical saturate scalar. Shift logical rounded scalar. Shift logical scalar. Okay, these one look new. Sign, extend, and widen lower. We probably reviewed something like this before.
So Igor pointed out that for sign and zero extend, they don't take a shift. These would largely be convenience overloads if we exposed them. They can be achieved by using shift left with zero, I believe, is the actual instruction alias. So whether we expose them is just a question of do we want to provide that convenience to end users?
I mean, does that mean that the JIT is going to understand that you called shift left logical and widen lower with the constant zero and omit sixtal because it's shorter?
It's actually the same instruction. Sixtal is encoded as signed shift left long with a zero immediate.
That's funny.
It's actually this. It's an alias at the assembler level, but it's the same encoding in hardware.
Okay, so if you disassembled it, it would be disassembler convenience to decide that zero meant show sixtal instead of SLL zero.
Right. There's actually a comment that says SX sixtal is equivalent to shushal, and sixtal is the preferred disassembly when the immediate is zero.
Okay.
Of course.
So this is not really an instruction, but it is an alias instruction alias that they talk about. So
yes,
if someone thinks in those terms, then I think having it here is fine. But then the byte shift parameter just completely disappears.
Mm-hmm. Right, the byte shift would drop.
Yep. And same with zero extend. It's just a alias instruction.
Yes.
Yeah, I think the name is fine, and the signature needs to match the instruction. And assuming that these summaries are making it somewhere into docs, they should also be correct.
What we really need is a voiceover commentary from Tanner where he pronounces all the instructions.
I think so far I'm the one making up all the pronunciations. But I'm happy to let somebody else come up with squish run.
So continuing just the pattern of concatenating our terms together in super long sequences. We've got shift right arithmetic, unsigned, and narrow saturate lower.
Yeah, so like, does your comment for sign extend and widen lower also apply to zero extend, widen lower?
Yes.
So they also are not required?
Yeah, they're not required, and if we did expose them, we would drop the shift parameter.
I see. Okay. All right, another Markov chain, shift right, arithmetic unsigned, and now saturate lower. I mean, it seems consistent with what we had before.
Yeah, I mean, you can insert the phrase "I want to" in front of it, and it makes a sentence. So.
And then the type name is on ARM64, right?
Yeah.
All right. Sign saturating rounded shift right, arithmetic unsigned, and narrow rounded right lower. That makes sense.
Does it though?
Well, I mean, to me the naming makes sense in the sense that it seems consistent in permutations of what we had before.
I hate to ask this question because I think it's been answered before, but do the size of all these names have an impact on metadata size or JIT string size or something?
Probably metadata size, because I don't think we're smart enough to split names apart in metadata format. I don't think it supported it.
Yeah, I think it impacts the string table.
I mean, that's a general question that I asked Tanner, I think, a while ago. Is like, what's the metadata impact of 3,500 or 5,000 intrinsics?
Well, so strictly speaking, we do have the reference assembly, and we've previously had JIT support for recognizing an external assembly for system numerics in particular, and supporting intrinsics on it. So we could, if it becomes a problem, move them out of corelib and into another assembly.
Well, I mean,
but I'm not
that
sure
just
that's
defers the
something we wanna
cost,
do.
right? You're not really eliminating the cost.
Right,
Well,
and corelib still needs them because we have implementations that are using intrinsics already.
Oh,
right. You just
yeah.
get away with a subset, though, right? I mean, that's what I'm saying. You're kind of deferring it just to the party that actually needs them, but like the overall encoding is still the same size. Probably even slightly larger if you have to split it because you have to shift it across the assembly boundaries. I think metadata is smart enough that if you use the same string for like hundreds of methods, I think the string is only encoded once. But given that we have these Markov chains, there's no reuse, right? That's the downside, I think.
Yeah, there'd be one entry for each unique name.
Right. And to make matters worse, I think metadata is UTF-16 too. I don't know.
I think the type names are UTF-8 rather than 16, but I might be wrong.
Yeah, actually, I don't remember.
Because there's two different tables. There's one that's UTF-16 and one that's UTF-8. I think its user string is 16 and type
that might be
names
true.
are 8.
Yeah, I think you're right. Yeah, it's not pretty. I mean, that's something that we need to consider, but also at this point, I don't know what to do about it because at this point, we're already halfway pregnant, right? Like we already have very long names in all the other instruction sets. So there's not much we can do, probably.
Something that could be done, but I'm not sure if it's necessarily a good idea due to how we support fallbacks for non-immediates, but many of these are essentially the same instruction, but with a flag for each different variant. So the underlying encoding between them is the same, and there's basically a question mark for rounded versus saturate versus not.
Right.
So we could do it as a flag, but.
So anyway, I'm not suggesting that we need to do anything. And maybe there's not actually a problem, and so we don't necessarily have to solve for a potential problem, but it might be something to understand at some point.
I think the only thing I've seen with two large strings is there's like Roslyn for their tests, since they use source or they use strings for all of their test compilation sources. They've hit the heap limit for user strings, but I don't think we're near hitting that for corelib for names here.
I mean, I actually like your idea of like maybe reducing the number of unique names by effectively taking parameters. That's actually not unreasonable.
The potential issue there is with how we support fallbacks. Essentially we'd have a lot more overloads that their indirect invocation fallback is a jump table.
Right. I mean, like, I think for the most part, the expectations people will have them as literals, right? In which case, they wouldn't. I mean, there's of course cost in the JIT to support, the fallback with jump tables, but
and then the other consideration is not all overloads of the instructions support all combinations of the flags. So some of them might only support rounding, some might only support saturation, some might support both.
Right.
And taking a bool is less than ideal.
Right. Yeah, I mean, like, let me just take the issue here and write it actually down. What was just said. I think I have the suspicion that as we're pushing this thing further and further, that eventually we will hit a point where we're like, no, the size is a problem.
Well, there's been discussion recently about AVX 512, and if we go that route now we're talking another 5,000 APIs and so forth. So, yeah.
Just make corelib not bottom of the stack.
Yeah. Let's ship a new platform that has a smaller corelib. Last time we did this, it went really well. Alright, so then there's a few more names. Shift right and logical, narrow, rounded, upper. Here you uppers. Shift logical and widen lower. Sorry, and widen upper again. Sign extend and widen upper. 0 extend and widen upper. I guess those are the same arguments as before, right? They're not strictly speaking required here.
Right, and if we do expose them, they drop the shift parameter.
Okay. Two more Markov chains here.
I guess it helps if my mute state matches what I think it should. So why in these three that are on the screen right now that say upper is the first variable named lower, and in the but it's not always?
What do you mean it's not always?
I feel like I just started seeing lower appear.
Yeah.
It's like 0 extend and widen upper took value. 0 shift right logical and narrow saturate upper took lower.
It seems most of your
and it has a value.
Is it intentional that it's lower? Or should this?
It's intentional that it's lower because it's the vector 128 that's returned. It's writing the result to the upper 64 bits, and lower represents the lower half of that result. So it's the lower 64 bits of the return vector.
So it's the operation based on value and count, or lower, effectively?
Right.
Okay, and should lower be the first argument or the last argument?
We've been matching the instruction ordering, in which case it's the first.
Okay, so all these things that take a extra vector called lower is what to do with the the lower bits in an instruction named upper, but the ones named lower didn't take an upper and they just set it to 0?
Yes.
Right, because the upper bits are always zeroed.
Okay.
And so you use both instructions to construct a full vector when you need twice as many bits for the result.
Okay. And there's no shift, right, logical, and narrow, saturate, upper, vector 64, vector 64. Like there's no, it does stuff and then moves it to the high bits and moves it into the vector 128.
Right, because it's going to be reading the upper half of value. Whereas the lower version only took a vector 64 because it always reads only a vector 64.
Okay. I've asked all my questions. We can move on now.
All right then. They look all consistent with what we had before. Holy shit. I think we just made it to the end. Can't believe we did it.
Igor's comment that he left for if we could still review it is fairly small, so it should be.
Let's take a look.
We'll either be able to finish it in the next 5 minutes or we won't. Since it's a previously reviewed API, and there was a question about the names.
Tautologies are so tautological.
Yeah, I was about to say the same thing. We either ship the feature or we won't. So before we do anything though, let me actually paste my notes, which is only like 4 kilobyte worth of text probably.
I think we actually got slightly over half of the APIs of the remaining APIs reviewed as well, so maybe we can finish them all in the next session.
I'm glad you're on record.
I said hopefully.
All right. Did I open the wrong one? Oh, okay.
So we had named them. Let me find the right group where we named them. I think we ended up naming them add returning high narrow upper. And Igor had a comment about the names might not be correct in calling them add upper returning lower and add upper rounded returning upper would be clearer.
What was the approved names? I actually forgot.
The name you copied into the last comment was add returning high narrow lower.
Okay,
I think the rationale makes sense to me because again we are ordering it in order of execution. So I would think that what Igor suggests makes sense to me.
Yeah, okay. But what's slightly weird to me, just pointing it out, is reading the name add upper returning lower, because the lower is going to get the result of adding the uppers, right? Like it's not only the lower, I guess it is the lower portion of adding the upper halves, because it's not going to spill into a let's call it 17th bit. So Okay, I guess it makes sense. I'm just thinking of the order of operations in my mind is take the two upper halves, add them together in a metaphysical concept, and then only take the lower half of that operation.
Actually, I came up with better name. Ima, can you scroll down a bit?
Down?
Yeah. So the name I used in implementation of this issue, it's add returning high narrow upper, add returning high narrow lower.
Are these the one here you're talking about?
Yeah. So I use this name after discussion with Summer.
Isn't it more add high returning narrow upper and add high returning narrow lower?
Guess what instruction does, if I remember right? So it adds vectors, elements, and take the upper high narrow part, basically takes upper part, narrow it down to the smaller type, and put it into upper or lower part, depending on the instruction.
Because if the add takes all the bits into account, then
it does take all the bits.
Then add returning high narrow upper is right. But the earlier description, I thought, said it took only the upper half of each of the operands and then added them together. So there's a question of if essentially the rounding that would come from both operands having the highest low bit set.
I can read instruction description. Basically, instruction adds each vector element in the first source, the floating point register, to the corresponding vector element in the second source register, places the most significant half of the result into vector, and writes the vector to the lower or upper half of the destination register.
Okay, so then based on that description, I agree add returning high narrow upper describes the order of operations correctly.
For multiply that does the same, we just call it multiply high rather than multiply returning high.
So you just want to add high narrow upper?
That would match the name that we've shipped for x86 for multiply high, and I think we've already approved for multiply high for ARM. Because we didn't call it multiply returning high, we just said multiply high.
Okay. Are there any instructions that would only operate on the high half of a thing where the word returning went would make a difference that you know of?
Not that I can think of.
Okay. So then if it matches the semantics of multiply, then I can add high narrow upper. I think the word returning makes it more clear, but if we have a consistency argument, then we have a consistency argument.
Yeah, I agree. I think it's more clear. I'm just calling it out for consistency with the other APIs we've exposed and approved.
So what would be the final name? Add high narrow upper. Right?
Mm-hmm.
Would you like to have an opinion, Emo?
Well, I stated mine already. Like, to me, it's all within the realm of slightly better, slightly worse. So I guess my care level is not that high. Because I mean, you can make arguments for either of them, right? And it just kind of depends on how you choose to think about it, which is very hard to predict.
Right.
So I mean, I can go either way. Like, to me, the biggest thing is we should try to be consistent with what we have, so that we don't reinvent this. But that seems generally hard because there's like so much nuance, right, for every single instruction. So that's.
Have we used the word returning in any of the intrinsics anywhere?
I don't think so.
Are you sure? Because that seems very familiar. I could swear we had this name used before.
I think it's because we spent like half an hour debating the names on this issue.
Because if returning is not currently in our Markov chain of names, then I think that we should be consistent and not add it here, even though it makes the name super clear.
Well, I checked and there's no returning on x86 and for ARM64 only those, since I already named them this way, named returning.
Okay.
I mean, maybe we talked about returning in another review, but I mean, I swear to God, I've seen that before. And it wasn't just in the last 20 minutes.
So yeah, if we've never otherwise used the word returning, then I can support add high narrow upper and add high narrow lower.
Okay.
Matches multiply and doesn't introduce a new term and saves 14 bytes out of the metadata table. That's called spin control.
All right. Then I guess this is not an issue that was more a discussion, so I'm not sure what to do with that in terms of sign off, but
I can just update the already implemented Intrinsics.
Yeah, that works for me. All right, so that means after this one, there's only these 3 tabs left.
Well, those 3 tabs plus there's the 2 that
you said will be ready.
Yeah, so I guess that covers all 3 of them. The middle one is still pending. The last one was made ready for review. And then I think based on my to-do doc I've got on my desktop here, there's a handful of miscellaneous ones which were widening or saturating that were missed.
I still think missing doubling instructions. Instructions that double the result.
Yeah, and then there was some float to integer conversion APIs, which I actually think I got up a proposal for already.
Okay, that's another solid 2 hours, just these 3 issues. Okay, let me book the time, and then I see you Thursday for the backlog review. We say backlog, but I think we never get to the backlog. We just keep piling new things on top. All right, then unless there's more questions, then this is it for today.
Thank you.
Thanks, everyone.